reversing it. So for our converse, if I have 6 plus 5 equals 11, okay, then 11 would also equal 5 plus 6 or 6 plus 5. Okay, so it's just flipping it. That's what that converse is doing. So for the converse of the Pythagorean theorem, if we have a squared plus b squared equals c squared, then you have a right triangle. Okay, where c is going to be the longest side. Okay, since your hypotenuse in a right triangle is your longest side, c has to be that longest side. So we can use the sides of a triangle to classify it as either acute, obtuse, or right. Okay? So in my chart here, for a right triangle, okay, that's if you have one angle is 90 degrees, right? One angle is equal to 90 degrees. For an acute triangle, all of your angles are less than 90 degrees. Okay, all of those angles have to be less than 90 degrees. For an obtuse triangle, you have one angle that is greater than 90 degrees. Okay, so those are the different types of classifications. We kind of went over that before with our angles. So using that converse, if we have c squared is equal to a squared plus b squared, where c is the longest side, okay, so c here would be your hypotenuse, that's the longest side. That means we have a right triangle because those are equal. Okay, that's how we were using the Pythagorean theorem before. Now for an acute triangle, if you have c squared is less than a squared plus b squared, again where c is the longest side, you have an acute triangle. Okay, so if you have that less than symbol, your longest side squared is less than the other two sides squared and added together, it would be an acute triangle. Okay, so c is still that longest side right here, and if you square that, square the other two, add them together, if that is shorter than those, it's acute. For an obtuse triangle, if you have c squared greater than a squared plus b squared, okay, where c, again, is the longest side, you have an obtuse triangle. Okay, so in each of these three, you're taking your longest side. Okay, you're taking your longest side and you're comparing it to the other two sides squared and added together. Okay, so that's what we're doing, and you should form it that way. So your longest side is going to go on the left. Your other two squared and added together is going to go on the right. Okay, so looking at some examples of this, I think it'll be a little bit easier when you see it shown to you. So we want to classify each triangle as acute, right, or obtuse. So the first thing that I do is identify the longest side. So you're given 3 different side lengths of a triangle here. In the first one, we have 7, 16, and 14. Your longest side is going to be that 16 value. Okay, it's the largest number, so it's your longest side. Okay, so that one is going to be your C value. Now the other two would be A and B. So if you want to label them, you can, but you don't need to. So I'll just label 7 as A and 14 as B. Okay, those are your 2 smaller sides. Now we're kind of going to form it like these 3 up here. Okay, so our C value is going to go on the left and A and B on the right. Okay, so we'll take our C value as 16 squared. Now since I want to compare these, I'm just going to draw in kind of a blank space there because I want to compare what's going on. My A value is 7, so I'll have 7 squared, plus our B value is 14, and that'll be squared as well. Okay, so from here you can use your calculator. I can take 16 squared, right? That's 256. Okay, again, I'm comparing it to, so I'm going to draw in that blank space. 7 squared is 49, plus 14 squared is 196. Okay, now I want to add those two numbers together, so I still have 256, and that will be compared to 245. Okay, so for your greater than and less than signs, when it's greater than, your greater than sign is going to eat that number. Okay, so since 256 is greater than 245, my sign is going to go this way. Okay, so 256 is greater than 245. So looking back up at my chart here, it's not equal, not less than, but it is greater than. So this is an obtuse triangle. Okay, so I'll write that this is an obtuse. And my triangle looks a little weird, but it is an obtuse triangle. Questions on the first one we just did? All right, I want you guys to do number 2. Don't do 3 and 4 yet. Just do number 2. Set it up the same as this one here. Okay, you can talk to each other if you need to. But I want you to work through problem number 2.
Thank you.
All right, so I'm going to go over number 2 here. Your longest side is 41. Okay, so 41 will go on that left-hand side. So 41 squared compared to 9 squared plus 40 squared. Okay, 41 squared is 1,681. That is compared to 9 squared is 81, plus 40 squared is 1,600. Okay, so next I'm going to add those two numbers together. So I still have 1,681 compared to 1,681. Okay, those are equal. And if I have my two sides squared and added together equal to that longest side squared, that is a right triangle. Questions on 2? All right, so number 3 and 4 have these square root symbols in them. I want you to keep the square root symbols in those numbers. Okay, don't take them away and get a decimal. If you don't know which one of these is your greater side, you can plug them into your calculator. Okay, get that decimal and compare all 3 of those decimals. Does that make sense? Kind of. So if I didn't know which one of these 3 was my greater number, I could take the square root of 5. Okay, I get about 2.2. Okay, then I could take the square root of 12. Okay, I get like 3.5. That's greater than 2.2. So right now, square root of 12 is the greatest. And then I could take the square root of 13, and that's 3.6. That's greater than what I just had for square root of 12. Okay, so in this case, square root of 13 is going to be my C value, or that largest side. But notice how I didn't write the decimals above it. Okay, you're not taking away the square roots. You're not writing out decimals for this. Keep the square root symbol in there. So since square root of 13 is my greatest side, it's going to go on that left-hand side here. Okay, so I have the square root of 13. And I'm going to put it in parentheses and square it. Okay, that is compared to the square root of 5 squared plus the square root of 12 squared. Okay, I'm putting the parentheses around it because what happens when I square a square root? Anything? What happens when I square a square root? It cancels. So your square and your square root will cancel. So what I'm left with over here is just 13. Okay, that's compared to, again, my square and my square root will cancel. So I have 5 plus square, the square root, that cancels. So plus 12. Okay, that's why you should leave it in that square root symbol, not put it in decimal form. Okay, so now I can combine these. So I have 13 compared to 17. Now 17 is greater, so we have 13 less than 17. Looking back up at your chart up there, that would make this an acute triangle. Questions on 3? All right, looking at number 4, again we have some square roots here. So again, if you don't know which one is your greater side, use your handy dandy calculator. So here, I'll try and fit this all in here. So I can take 2 times the square root of 3. Okay, that is equal to about 3.5. Okay, moving on, if I take 4 square roots of 4, okay, that's going to be 8. Because I can take the square root of 4. So the second one's 8, that's greater than 3.5. The third one here, we have 3 square roots of 5. Well, that's only 6.7. Okay, so that middle term was our greater number right here. So that's going to be your C value. Okay, again, when I'm plugging this in, I'm going to put parentheses around my term here. So I have 4 times the square root of 4 squared compared to 2 times the square root of 3 squared plus 3 times the square root of 5 squared. Now I'm putting parentheses around this because you do need to distribute your square to both of those terms, okay, within that parenthesis. So I need to square that 4, and I need to square that square root of 4. Okay, so if I square 4, I get 16. And if I square this square root of 4, I just get 4. Okay, and those are multiplied together. Compared to, I need to square 2, so I get 4. And I need to square the square root of 3. So again, I just end up with 3 there because those cancel. Plus square 3, that's 9, times, we're going to square the square root of 5, so those cancel. I'm left with 5 there. Okay, now I can multiply these numbers together. So I have 16 times 4, that's 64. Compared to 4 times 3 is 12. Plus 9 times 5 is 45. Add those together, so I still have 64 over here compared to 57. Now 64 is the greater number. Okay, so we have 64 greater than 57. So that is an obtuse triangle. Questions how I did this one? So when you have problems like this, make sure you do distribute that square. Okay, those numbers are multiplied together, so you need to distribute that square. All right, so looking at the back, number 5 is what we did yesterday. Okay, you're using the Pythagorean theorem and you want to solve for x. Okay, so first identify your sides. It is a right triangle. We're given it is a right triangle, so they are equal. Okay, so opposite that 90-degree angle is the hypotenuse, or your C value. Your other two sides are your A and B values. Okay, so your legs are those A and B values. Then I can use the Pythagorean theorem here. So A squared plus B squared equals C squared. Again, I can say they're equal because I already know it's a right triangle. So plugging those values in, for A I have 16, that's squared, plus B is 33, that is squared. That's equal to, our C value is x, and that'll be squared. From here I can square 16, that's 256, plus 33 squared is 1089, and that's still equal to x squared. Add those two together, I get 1345. It's equal to x squared. I need x by itself, so I'm going to take the square root of both sides. Again, when I do that, I usually get that plus or minus. Okay? In this case, it's only going to be the positive answer because we're talking about length of a side of a triangle. Okay? So our x value is equal to the square root of 1345. If you want to plug it in and get a decimal, you can, but I didn't do that, so I just have the square root. Good? I don't know what the decimal is, so there. Questions on 5? All right. Number 6, you're not given this is a right triangle. So number 6, you're doing what we did in the first floor problems on the front. Okay, so you're comparing to see if it is indeed a right triangle. So first thing I need to do is identify my longest side. Well, I don't know if 10 times the square root of 3 is longer than 20. So I'm going to plug that into my calculator just to make sure. Even though it looks like 20 is the longest side, don't assume that. Okay, so if I have 10 and then square root of 3, okay, that's only 17.3. So 20 is the longest side, so that's going to be your C value. Okay, and just like we did on the front, that's going to go on the left-hand side of that equation. Okay, so we'll take 20 squared, and we want to compare that to our other two sides squared and added together. And then for that 10 square root of 3 piece, I'm going to put that in parentheses because I need to square both of those terms. Okay? So just simplifying here, I have 20 squared is 400 compared to 10 squared is 100 plus distribute that square to both terms since they are multiplied together. So I have 10 squared is 100 times square root of 3 squared. Those cancel, so I'm left with 3. Okay, so I still have 400 compared to 100 plus 300. Okay, so we have 400 compared to 400. Those are equal. So, yes, this is a right triangle. Okay, so yes, that would be a right triangle. Questions on that one? All right, so I'm not going to go through 8, but I am going to go through 7. Okay, so you have, I think, 2 problems on your assignment that are similar to number 7. So here we are already given that this is a right triangle, right? So they are going to be equal. So I can say they're equal right away. I don't need to compare the sides. So now I want to label each of my sides. So the side across from that 90-degree angle is C. So your other 2 sides are A and B. Again, you can interchange those. They don't always have to be specific. Now I want to plug it into the Pythagorean theorem here. So A squared plus B squared equals C squared. I have my A value as 9. So I have 9 squared. Plus my B value is x minus 3. So I'm going to put parentheses around that x minus 3 and square it. Okay, that's equal to, C is x, so we have x squared. So I'm going to simplify here. This 9 squared is just 81, right? Okay, I'm adding. Now this x minus 3 squared, can I just distribute this square to both numbers? Can I distribute that square to both numbers? No, no you cannot. Okay, the reason we could here, I want you to know this is the difference. Here, what is different between this and this? There's this subtraction here. Okay, so you can distribute your square when you have 2 numbers multiplied together. But if you have addition or subtraction between the 2, you cannot distribute that square. Okay, so off to the side, what this is actually saying is I have x minus 3 times x minus 3. Okay, that's what that square is doing. It's multiplying that number times itself. So you have to FOIL it. Okay, so you have your first or front, your outer, your inner, and your last. Okay? So here, multiplying x times x, you get x squared. X times this minus 3 here will be minus 3x. Okay, next we have our inners. So that minus 3 times x, then we get minus 3x. And then negative 3 times negative 3 is positive 9. Okay, I can combine like terms right here. So I have x squared minus 6x plus 9. Now this whole term right here, I can plug in right here after I squared it. Okay, so I have plus x squared minus 6x plus 9. Okay, so again, I'm taking this, bringing it back over here. Okay, that is equal to x squared. Okay, next what I'm going to do, I'm going to subtract x squared from both sides. What happens? They cancel on both sides. So I have 81 minus 6x plus 9 equals 0. Okay, when they cancel on that right-hand side, it's equal to 0. It doesn't equal 1, doesn't go away. Okay, it's 0. I can combine these two numbers, right? 81 and 9. Okay, it's 90 minus 6x equals 0. I'm going to add 6x to both sides just so I can get that x value on one side of my equation. So I have 90 is equal to 6x. I can divide both sides by 6. So x will be equal to 15. Okay, so you do have two problems like this on your assignment. They're on the back side. Okay, you do still need to know how to FOIL, when to FOIL, and when to distribute a square. Okay, they're different. So if you have subtraction or addition, you have to FOIL. If they're just multiplied together, you have to distribute. Okay? Questions?